Yeah, don't quite have them finished today, but I will have tests ready for you to look at Wednesday. And probably it's a good possibility that they'll be on Canvas tomorrow night, either tomorrow night or be during the day tomorrow. But by class time, they'll be ready. Yep. Mm-hmm. Yep. All right. We got a new sign-in sheet going around. Okay, we filled up our old ones. Okay. All right. So we are moving into a new chapter. Okay. In chapter 4, we're using rates and ratios and percentages. Okay. It's not real mathematically exciting, okay, but it is useful. Okay. It's the kind of stuff that you use day to day. A little rowdy this afternoon. You're okay. You gotta stay rowdy when we're doing the math problems too. You can't look like zombies when we start doing math. If you're gonna have energy now, you gotta keep a little bit of it. Okay. All right. So anybody have any just general questions before we get going? Nothing? Okay. So looking ahead, I know we just took test 1, okay, but looking ahead for you planners, I know some of you like to plan way out. It's looking like, okay, it's still kind of up in the air, but it's looking like test 2 is going to be probably October 20. Okay. If anything changes on that, I'll let you know, but right now that's how it's looking. Okay. So midterm is just the middle of the semester. We won't have like a specific exam or anything for it. Yeah, so for us, our midterm grade will be our test 1 grade and whatever Hawks is at that point in time. So, yeah. And then, so that's something else to talk about. A lot of you are freshmen, right? So you might not be aware, but you don't get a midterm grade unless you have a D or an F in the class. Okay, so if you don't get a midterm grade, that's good. Okay. It means you're passing. So. Okay. All right. Dun, 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 dun. Okay, so let's look at some rates and stuff. Okay. All right. Okay. So let's talk about what we mean by saying a rate. If we're talking about a rate of something, we are a little bit vague with our definition here, and it'll kind of overlap with our definition of ratio. And there's a little bit of gray area there. That's okay. Our definition here just says we're writing it as a fraction. Okay, something we write as a fraction to compare 2 quantities, and they don't necessarily have the same units. Some textbooks would say they definitely do not have the same units. Okay. But it is a little bit of a gray area. Some people call it a rate, even if they do have the same units. So. But the idea is we're just comparing 2 quantities with a fraction, okay, which is what we're doing in most of this chapter. Okay. So there's, yeah, okay, that's it. Sorry, I was starting to say something that's not true. Okay. Thinking ahead. Okay, so let's write down some rates. Okay, this problem, we're not trying to like necessarily calculate anything. We're just trying to write down the rates. And it'll make more sense when we look at it. Okay. All right, so this one says we're gonna go spend some time with our friends on Friday night, and we're trying to figure out what we're gonna do. So one option, okay, is we've got laser tag. There's a couple of different deals we could consider there. It's $13 per person for 2 games, or $18 per person for 3 games. Okay, so there's 2 options. Then we've got option number 3. It says we could go to the county fair and do all we can ride on the rides there. And we just want to write down the rates for these 3 options so that we can then make a decision. So it's not asking us to make a decision here. We're just going to write down the rates, and then the friend group can make their decision. Okay. If you do much getting together with your friends and trying to make a decision, you know how hard it can be sometimes. Maybe these rates will help us. So let's go with laser tag number 1. We want to write down the rates here. Oh, we do have a little bit more information. I'm sorry, I forgot. Okay. As far as the time, we're guessing it's going to take us about 30 minutes per game of laser tag. And then for some reason, we've decided if we go to the fair, we're going to stay from 8 to 10. Okay, so 2 hours there. Okay. So option number 1, I'm going to call laser tag 1. And we want to write down the rate for that one. So that first one says it's $13 for 2 games. And since we're trying to make a comparison for all 3 of these, instead of calling it so many games of laser tag, we can't do that with a fair, so it's probably best for us to think about how long we're going to spend. So if we're going to play 2 games here, and we're saying 30 minutes per game, we can multiply by 2 and say we're going to spend 60 minutes. So for laser tag option 1, we would say we're going to spend $13 for 60 minutes of laser tag. And you could change it to an hour if you wanted to, but it doesn't really matter on this one. It just wants us to write down the rates. Okay, so that is a rate. It's a fraction. We're comparing 2 values. Okay, so our other option, laser tag 2, $18 for 3 games. So if it's 30 minutes per game, that'd be 90 minutes. Okay, so $18 for 90 minutes. You could do an hour and a half if you wanted to write it down that way, but do in minutes. Doesn't really matter. Okay, and then option number 3, we've got the fair. And how much was it? It was $20. And we've decided we're going to stay for 2 hours if we're doing that. So $20. And then just since the other 2 are in minutes, I'm going to write this one in minutes also. 2 hours would be 120 minutes, but it doesn't really specify. It's just nice for them to all be the same so we can make a easy comparison. So on this one, we're just using those as a decision-making tool. Okay? So one way we're comparing here is how much money we're spending, and then how much fun we get to have as far as time. Okay? There's not a right or wrong answer on this one. It just wanted us to write down all the rates. It would be subjective on which one you would rather do. Questions on writing those down? Not bad, right? Okay. That's a rate, though. That's a rate. Let's look at another one here. This one, let me get through all this. Oop. So it says Foods in Bulk, which I guess is a store, offers 30 pounds of candy for $64.49 on its website. Which of the following fractions represent the rate given by their website? What do you think? B? Okay. 30 pounds of candy for $64.49. Okay. We've actually got another one. D works also, okay? So I see why you would say either one, but both of them are really correct because you can think about it either way around. You can think about it that we're getting 30 pounds of candy for this price. That's kind of the way it's worded, so I see that's why you would go for that one. Okay. But you could also say we spend this much money and get this much candy. That's still a rate. Okay. So unless it specifies, rates can work either order. A and C are not rates because they're not comparing two different things, right? They're not comparing things with two different units. We just got a 1 on the top there and 1 on the bottom there, so it's not making a comparison. No units, so A and C are not rates. Okay. All right, let's look at one that you probably have to deal with a little bit. The fuel mileage. Okay. Says as a college graduation present, Katie's parents helped her buy her first new vehicle. That was nice. Okay. Says she chose one that claims a fuel efficiency of 29 miles per gallon, or short for that's MPG, on the highway. Check the actual miles per gallon on Katie's new car if she drove 309 miles on 11 gallons of gas. So if we're trying to find a specific rate, we just saw you can do them either way, right? You can put either number on top or on bottom if it doesn't specify. But if it's telling us to find a specific rate, it usually specifies which one needs to be on top, which one needs to be on the bottom. So we've got a keyword in here, it's per. So if you see per, that means divide, or since we're dealing with fractions, you can think about that means the fraction bar. So for us to calculate this rate here, which one do we want to go on the top? We want miles per gallon. So we want miles on the top, then the fraction bar, and then gallons. So you drove 309 miles per, that's our fraction bar, 11 gallons. Okay. And if we want to figure out miles per gallon on this one, all we have to do is divide. Okay. So fraction bar means divide. Okay. So we do 309 divided by 11. And it doesn't tell us how to round, so I'm going to round to 2 decimal places. Okay. So it's a little bit over 28 miles per gallon. Okay. What do you think? The claimed fuel efficiency is 29 miles per gallon on the highway, and then her actual fuel efficiency here is 28, a little bit over 28 miles per gallon. What do you think? Think that checks out? Pretty close. I don't know how much you know about fuel mileage, but usually if you're shopping for a car, it gives you 2 different fuel mileages. Now they're giving 3s on some of them, but so it'll give you the highway. You get better fuel mileage on when you're on the highway, not having to stop at traffic lights and things like that. So that number is usually higher, and then they'll give you a city fuel mileage, which is when you're in traffic and having to stop at traffic lights and those things, and it's a little lower. And we don't know what kind of trip she took, so for it to be really close to the highway fuel mileage, it's really close to the high side, so it looks pretty good. Some of them give you combined now too. They've got some kind of formula where they mix the highway and the city fuel mileage and give you a better idea what you can expect on average. Questions on that one? Anybody keep up with your fuel mileage in your car? No, okay. Nobody does? Yeah, some of them, yes. Some of them, yeah. If you got a battery, that really, yeah. Most of the cars I've driven in my life have been pieces of junk. So if that's the case, you really want to keep up with fuel mileage because a lot of times on the old cars and stuff, fuel gauge doesn't work anymore. So you really want to know what kind of fuel mileage you're getting so you can keep track of how much gas you've got left. Okay, go to the next one. Look at this one. It says if rice costs $7.99 for 5 pounds, determine the cost per pound of the rice. Again, the main thing, you just got to make sure that you're getting the numbers in order because it tells us a specific rate we're looking for. We're looking for cost per pound of rice. So we want the cost on top. Per, we're dividing. And then pounds of the rice, we've got 5 pounds. And then we can divide that out. So 7.99 divided by 5. Let's see what we get. So pretty much $1.60 per pound. You round it to the nearest cent. Okay, questions on those? Okay. So something we can do with these rates is if we have some unknown quantity we're looking for, but we have a rate, and we can set up what we call a proportional equation to figure out our missing value. So you've probably seen these before. It's just when you have one fraction equals another fraction. It's our rates are fractions. Okay. And we call those proportional equations. So let's look at using one. These are really useful. These are come up a lot in life. Okay. All right, so back to our fuel mileage problem. It says how much gasoline should Katie have used after driving 243 miles in her new car that boasts 29 miles per gallon? Okay. So it gives us the rate of 29 miles per gallon. So we can use that as one side of our proportional equation because it says she's supposed to get 29 miles per 1 gallon of gasoline. Okay. That's our rate. And if that's the rate, then if she drives 243 miles, we want to know how many gallons of fuel that should take. Okay. So when you set these up, you just want to make sure your units match. Okay, so I've got miles on the top of both of them, gallons on the bottom of both of them. And then what can we do to solve these things? Anybody remember if you've got a proportion like this? What do you do? Anybody? You can take a wild guess if you're not sure. Cross multiply, yeah, cross multiply. Okay. So we're multiplying diagonally, kind of what we call cross multiplying. So I'm going to do the top of the left side times the bottom of the right side. And I'm not going to worry about the units. You can be very particular about these. And if you're in science class or something like that, they might make you keep up with the units. But here, I know our answer. What units is it going to have? It's going to be in gallons. Okay, so I'm not going to worry about keeping up with units through the problem. So I've got 29 times x, 29x. And do the bottom of the left times the top of the right. That one's easy. 1 times 243, that's 243. And then what do we do? Yeah. Divide both sides by 29. So I'll write our answer up here so you can see it better. 243 divided by 29. Okay. That's like yeah. If you round to two places, that's like 8.38 gallons. So do a little squiggly equal there for rounding. Questions on that one? Good. All right. Okay, so one other idea here, and I think that's about it, yeah. One other idea in this section, and we've already used a couple of them, like when we're using miles per gallon. The thing that's special about this rate is the bottom, because on the bottom we have 1 as our number. Okay? So we give rates like that a special name. They're really useful. They help us in calculations like this, and they help us think through things because we have that nice 1 on the bottom and not some weird number. So these things we call unit rates. Okay, let me get there, sorry. I gotta have all these in here. Okay, we call them unit rates. Okay. So anytime we have a single unit on the bottom in the denominator, call that a unit rate. Okay. And we also, not only the miles per gallon, we also dealt with the unit rate when we had that one. That was how much money are we spending per pound of rice. And these are really nice when you're shopping and doing price comparisons. A lot of stores even put it on the little tag on the shelf what the unit price is. That's kind of what this next problem is going to look like. Look at this one. So we're comparing 3 different types of wood mulch at the local garden center, trying to make a decision on which one we're going to buy. So to do that, we're going to look at the unit rate or the unit price. And usually the way we set these up when we're doing price comparisons is we want to figure out the price per whatever unit we're buying. Okay, so here that would be the price per cubic foot. Okay. So A for pine bark, we'll put the price on top and then divide by 3 cubic feet. And if we get our unit right there, the way we do it is we just divide just like we've been doing. So 3.77 divided by 3. Now I'm going to round to the nearest cent on this one. So this one comes out to be about $1.26 per cubic foot. And then we just do the same thing with the other 2. So the idea, before we do those, the idea is it's a little hard. This one's not terrible, but sometimes depending on the numbers that are involved, it's even harder. It's a little hard to make a nice, easy, just direct comparison, like which one of these is more expensive, or even if you can tell one's more expensive, how much more expensive is it? And so that's where the unit rate's really helpful. So let's do B. We got cedar mulch, $3.98 for 2 cubic feet. See what that one comes out to. So 3.98 divided by 2. It's $1.99 per cubic foot. And the last one was it evergreen red mulch was $3.33. per 2 cubic feet. Now, 3.33 divided by 2. If we round, that's about $1.67 per cubic foot. So then once we had the unit rate, like if we were doing some kind of project, right, we would have estimated we need so many cubic feet of mulch for our garden or whatever we're doing. Okay. And then we could decide, well, is the cedar mulch that much better than the pine bark mulch that I'm willing to spend like 50% more on the price, right? Because it's $1.26 for the pine per cubic foot, or $1.99 for the other one per cubic foot. So maybe it is. Okay. Not a right or wrong there on this one necessarily. So. But at least we can make the comparison. Okay. Questions on that one? One more problem here. We're going to skip over one. I know these are not real exciting. Get through the mulch here. Okay, let's look at this last one. It's really a multi-parter here. We got 2 things to figure out. It says Emma's traveling to Italy for spring break. She's preparing herself for all the shopping she has planned by looking at the exchange rate between dollars and euros. Ensure that she does not overspend while there. She wants to have in mind the equivalent dollar amounts for euro prices. And we've got a table on the next slide with the exchange rates. And this table is a little confusing to me, or in my opinion. What this is telling us is that if we have 1 euro, that's this many dollars. Okay? Or if we have $1, that's this many euros. Okay? So it gives us the exchange rate both ways. And on this problem, we don't care about the others, but they're there. Okay? Our textbook's a little old, so I don't know how close some of these are now. Okay? Haven't really looked at them lately. Okay. Then we've got a few questions. So A says, what's the unit exchange rate for American dollars to euros? We saw that. That was our first one. Okay. B's going the other way. We looked at that. Okay. C's more interesting. It says, if Emma's considering taking $200 for spending money, approximately how many euros will that be? Okay. So we need to set up our equation and use one of the rates. Okay. Really, you can use either one. Okay. Just the algebra will work out just a little bit differently. But if we're trying to change $200 into euros, okay, it may be best to use this, that if we have $1, it's this many euros, 8.740192. Okay. We'll set up our equation, so let's set that up here. Okay, so C, we've got $1 was 0.740192 euros, and I'm not good at writing the symbol for euros, so I'm going to do the shorthand there. That equals, okay. Now dollars was on top, right? So she's taking $200. We'll put our $200 on top, and that's going to be some value we're looking for in euros. Okay. That one works out nice for us, because if we do $1 times X euros, we just get X. So to figure out the other way, right, we just do the multiplication. 200 times 0.740192 we get about 148.04 euros. Make sense on that one? Okay. That's good. I got one going the other way, but I think that's fine. You can do it one direction, you can do it the other direction. Okay. That's 4.1. Just dealing with rates. Several of the problems in that homework assignment are just write down the rate. You're not having to do any kind of calculation, but then there are some that say find the unit rate, like we did with the mulch and with the rice. Let's look at 4.2. This is not a very long section either. These sections in chapter 4 are pretty short. All right, so 4.2, instead of dealing with rates, we're dealing with ratios. Okay, and depending on who you're talking to, there's not a lot of difference between the two. Our definition here is still a fraction used to compare two quantities, but here our definition says that their units are the same type. So some people will still call these rates, even if they have the same units. It doesn't really matter which one you call them. You call it a ratio or a rate. But in this section, our units will be the same. Okay. And the thing about ratios, if you say that they have the same units, then that gives us multiple ways to write them down. Okay, we don't necessarily have to write them in a fraction with one unit on top, one unit on the bottom. And so the same unit, we can really write a ratio 3 different ways. Okay? And it doesn't matter which one you use. Okay? We can write a ratio in words. Okay? So like we could say there's a ratio of 1 to 2. Okay? Or you can put a colon between the numbers. You may have seen that one before, and you read it the same way. Okay, you say there's a ratio of 1 to 2. Okay? And then a fraction also works. Okay? So we can write it just like we were in the last section with the rates. We would still say you can still read that there's a ratio of 1 to 2 with it in fraction form. Okay? Or you can say it's 1/2. That's okay also. Right. So any of these 3 are okay. Just pick whichever one you like. Usually the fraction way is a little bit easier to work with when we're dealing with it in an equation. Maybe any of them are okay. Okay. So let's see, let's write one down. Let's write down a ratio. All right, so this one says on a university campus, the fall enrollment shows that the new freshman class consists of 321 women and 214 men. Write the ratio of men to women. Okay. Again, really the only thing you have to pay attention to on these are the order that you're looking for stuff to be in. We want men to women. Okay. And we've got 3 different ways we could write it. Okay, we could say 214 men to 321 women. That would be okay. And on this one, okay, you want to try to write them in lowest terms usually because it's easier to think about. On this one, you would be forgiven if you did not realize that 107 will go into the top and the bottom. Okay. That's not easy to see. But if you divide the top and the bottom by 107, okay, then we can say there's 2 men to every 3 women. Okay. So that would work. Or we could say it's 2 to 3. Or we could say 2 to 3 with a colon. Any of those are okay. And I know we said with a ratio they have the same units. Here the idea is that the units are people. Okay? So a little bit of a gray area there. Questions on writing those down? Yeah, so what on this one we divided top and bottom by 107. I know that's not easy to see. So get 2 to 3. Okay. So something else we want to talk about, and we've really used it here, okay, is the idea of equivalent ratios. Okay. So really for any type of relationship we want to represent, there's an infinite number of ways we can do it. Okay. So the idea is if we have a ratio, like we have a ratio of 3 to 5, okay, well, we can multiply or divide the top and bottom by the same number and get an equivalent ratio. All right, so like if we multiply top and bottom by 2, right, 6 to 10, that's the same relationship, that's the same ratio. Okay. Or we can multiply top and bottom by 1,000. Right, and that's the same ratio. Okay. An equivalent ratio. You can divide also. Normally we leave the top and bottom as whole numbers. You could take 3 over 5 and divide top and bottom by 2 and have like 1.5 to 2.5. There's technically nothing wrong with that. It's a little weird. We don't use it much, but it's okay. So all of those represent the same relationship, so they would all be equivalent ratios. It could be equivalent, as long as the idea, the way I got here, right, is I divided top and bottom by 2. So as long as you're doing the same thing, as long as you're multiplying or dividing the top and bottom by the same number, you get an equivalent ratio. Yeah. We use the idea when we simplify fractions. Right? Like if we have 4 over 6, we'll say, well, you need to write that in lowest terms. Right? That's the same idea. Yeah. Okay. All those are equivalent. Okay. Let's look at another ratio here. Look at this one. So these we just have to read carefully. Okay, this one says a local radio station says that out of every 10 listeners, 6 are women and 4 are men. Write the ratio of women to men listeners. Oh, so this one's not as tough as I thought it was. Okay. So just make sure you're getting the right numbers in the right place. On this one, we want women to men. So we've got 6 to 4. Maybe we write it that way. Or we write it 6 to 4 or 6 to 4. And it says put it in lowest term, so it's just like reducing a fraction. 2 will go into both of these, so we could either call it 3 to 2, or 3 over 2, or 3 to 2. Any of these are okay. Okay, let's look at this one. This one, there's just a little bit of a curve on one part. All right, so we've got the list of the top 40 under 40. And it says it includes 15 women. We want to write the ratio of the number of women on the list to the total number of adults on the list in all 3 notations. Okay, so we want women to the total on this one. Okay. So it says our list has 15 women. And then how many total adults do we have on the list? 40. Yeah, 40. Okay, so before I write it out in all three forms, I'm going to go ahead and put it in lowest terms. And so it's just like reducing a fraction here. 5 will go into top and bottom, so we could call this 3/8. Divided by 5. Or we could say 3 to 8. Or 3 to 8. Any of those are okay. B, we've got a little, this is where we have to think a little bit more. We've got a little bit of a curve. It says write the ratio of women to men. It doesn't tell us how many men, so what can we do? Yeah, so we know the total. So the idea here, we subtract. Okay. So then 15 women, 25 men. Or we can simplify that, 3 to 5. Questions on that one? Hanging in there? I know these are just, you're fired up about go out and tell somebody about ratios. Class, that's just, this chapter is not all that exciting, okay? I'll admit that. But it is stuff that we use all the time, okay? So it's good to have a handle on it. Okay. All right. This next one, we're not going to calculate anything. I just want to show you one way these ratios are useful in making comparisons. So we're going to just look at one together. Okay. Get through this. All right, so the idea here, I'll give you the summary. Okay. Not sure how much of a health nut you are, okay, but we've got 2 different types of fatty acids in our diet that we talk about a lot. Okay, we've got the ones we call the bad fats, okay, the fatty acids called omega-6, okay? And then we got the ones that we call the good ones, okay, that we call omega-3. And it's not that one's good and one's bad, it's that in our bodies we want to have a higher ratio of omega-3 to omega-6. And in the general American diet, we have a lot more omega-6 than we have omega-3. So it's supposed to be better for your heart if you have more omega-3. Okay? So we've got a number given here to us that says in farm-raised tilapia, the ratio is 11 to 1. Okay, so which one's which here? That's the omega-6, the bad ones, to the omega-3, the good ones. So saying we got 11 bad ones for every 1 good one we have. Okay. So we want to compare that to some other types of fish, okay? Because the idea is to be healthier for your heart. Okay, you want a higher ratio of omega-3s. Okay? And fish is a good way to do that generally. And so if we look at our table here, okay, we got the bad fatty acids here, the good ones there, okay, for several types of fish. Okay? And we want to compare that to the farm-raised tilapia. Okay? The idea is it's not real easy to see here. Like we could write these as ratios. Okay? What we do, I'll make it the left column or middle column to the right column. Okay, if we do that, we get the ratios. But it's not real meaningful to most people's brain when you got these real big numbers involved. Okay? So to make it easier to make a comparison, what we would generally do is we're going to take and divide everything by the second number, or the denominator if you're thinking about a fraction, right? So that we get a 1 on the bottom, and then we can just compare the tops, or compare the first numbers, and it's easier to make a comparison. So if we do that here, okay, we get decimals on the top, that's okay. So here's what we got going on. We got the bad fatty acids for every 1 good fatty acid. And then got these types of fish comparing it to farm-raised tilapia. So what's it look like? If the bad ones are on the left, the good ones are on the right. Does it look like farm-raised tilapia is a good option? No, not really. And I don't know if wild tilapia is like that or not. I have to look into it. But looks like all of these are way better for you than farm-raised tilapia. Okay. This one's got 11 bad for every 1 good, and these have like just partials of a bad for every 1 good. So what's the best on the list? Herring. I would much rather go with the salmon personally. Or I know everybody says it different. Okay, salmon. Some maybe say salmon. So. I don't even know what that last one is. Anybody know what that, the one right before tilapia? I don't know either. And I don't know. I have to Google that later. That's just a thinking problem. Okay. We got like just a few more, not many more. Okay. Let's look at this one. This one's really useful. We got a map. Anybody know what a map is anymore? Everybody uses electronic maps now, right? Everybody uses their phone. That's okay. You have the same type of thing on here. So the idea is we've got what they call a scaling factor on the map. It's on Google Maps too. You just might not pay attention to it. It tells you here that every 1 inch on the map is 5 miles in real life. And then we've got a couple questions. So A says if the distance on the map between point A and point B measures 3 inches, what's the actual distance between these points? So we use our scaling factor. Okay, this one might be easy enough. You can just figure it out without writing down an equation. Okay. If not, it's not bad. Okay, so it says 1 inch is 5 miles. Okay, so here's our scaling factor. 1 inch is 5 miles. And we want to know if we're looking at 3 inches on the map, how many miles will that be in real life? Again, that one you might be able to just figure out without having to do the equation, and that's fine. But if we cross multiply here, we get 15. Okay. That's 15 miles. Okay. That would make sense. B's a little bit trickier. Not quite so easy. It says if you wanted to take an 11-mile walk one day, what distance would that be on the map? In inches, so we're going the other way this time. So we can still use our scaling factor. It might be easier to flip it upside down on this one. Say 5 miles is 1 inch. And because we want to walk 11 miles, and we want to know how many inches that would be on the map. So then if we cross multiply, we'd have 5x equals 11 divided by 5. Get some decimal here. What's that? Yeah, 2.2. 2.2 inches. And you can set it up with inches on the top. That's no problem. You just got to make sure they match. So if you did your scaling factor like we did up there, you did 1 inch to 5 miles. you would say X inches to 11 miles. There's nothing wrong with that. Gotta make sure they match across. Question? No. Okay. You know. This one's similar. When we get there. But we've got to come up with our own scaling factor this time. It says the distance from Chicago to Albany, 816 miles. On the map, the distance from Chicago to Albany is 1.4 inches. We want to use that, come up with our own scaling factor to figure out how far it is from Chicago to St. Louis if the distance on the map between these two cities is 0.5 inches. Okay. So there we can come up with our own scaling factor if we take the miles, 816 miles, divide that by the distance on the map, 1.4 inches. So if you want to, you can think about it like we're dividing top and bottom by 1.4. Okay, so that's about, rounding a little bit here, 582.6 miles for every 1 inch on the map. Just dividing by 1.4. Okay. And now what? Now we use our scaling factor we just came up with to figure out how far 0.5 inches on the map would be. So I think I've got some room here, yeah. So here's our scaling factor. We want to know how many miles. That's got to go on top because I wrote miles on top on the first one, is 0.5 inches. And then we cross multiply. So X is going to be 582.86 times 0.5. $291.43 miles. Okay. Not much harder, just coming out with their own scaling factor. Anybody bored? But just to be honest, anybody bored? Okay, we're almost done. We got some boring sections in this class, but not all of them. Some of them are a little more interesting. Let's do, I've got 2 examples left. Let's do one more and then we'll leave the other one for Wednesday. About that. Okay. So one other thing, okay, this one is a little bit different, so maybe it'll be not quite as boring. Okay. When we're dealing with ratios, one thing we can encounter is when we have a ratio with multiple parts. Okay? So what we got on this one? We just want to be clear on how to deal with those. Okay? So here we got a mix of nuts. We got cashews, almonds, and Brazil nuts. And it says they go even further to say that the ratio of cashews, almonds, and Brazil nuts is 2 to 3 to 5. Okay? So you got to be careful before you get started on this to make sure you know which type of nut, which part of the ratio goes with. Okay, so it's in order that they give them to us. So here 2 is cashews, 3 is almonds, and then 5 is Brazil nuts. Okay. If you get that mixed up trying to work with it, it's going to be a disaster. Okay. And then it tells us we've got 5 ounces of cashews in each bag. How many ounces of the other 2 types of nuts do we have? Okay. So the nice thing about having one of these multi-part ratios is that as long as we know which type of thing deals with which part of our ratio, we can just pick any two pieces. So like we could work with 3 to 5, or we could work with 2 to 3, or we could work with 2 to 5. And we can just ignore whichever piece of it we want to. Okay. You don't have to try to use the whole thing. So it doesn't matter which one we find first, but since it tells us we have 5 ounces of cashews, that's one of the numbers we're going to work with. And then we'll figure out almonds and Brazil nuts here. Okay. So I think I'm going to do Brazil nuts first. It doesn't matter which one you do first. But so setting up my equation, okay, I know that in my ratio, cashews are a 2, and that represents 5 ounces in the bag of mixed nuts. So I've got 2 cashews, and that's 5 ounces. So that's cashews. Then I'm going to find Brazil nuts next. So on my ratio for the Brazil nuts, that's the 5. And I don't know how many ounces that is. That's what I'm looking for. Okay. So then I know it's getting old. Okay, we can cross multiply. So we'll have 2x equals 25. Divide both sides by 2, so we get 12.5 ounces. So that's our Brazil nuts. Okay, so that's part of it. Now we've kind of filled in some missing information. Okay. And you can just choose which information you use to set up your equation for the last one. And there's lots of possibilities. Because here now we know Brazil nuts 12.5 ounces. So either you can do cashews again and do cashews and almonds just like we did that one, or you can use the information you got with Brazil nuts and do that in almonds and figure it out. Doesn't matter. Okay. I guess I'll just use cashews again. Okay. So here, if we're working with cashews, just like it was before, 2 to 5 ounces. And then now I'm looking for almonds. And my ratio almonds was a 3. X ounces down here. Cross multiply, works just like the last one. Divide by 2, we get 7.5 ounces. So we got 12.5 ounces of Brazil nuts, 7.5 ounces of almonds. The last one is a multi-part ratio. It's just a little bit different. We'll work it at the beginning of class next time. Okay, how's that sound? Good? And I have your test to get back to you next time too. So. Okay. No, it's a boring Monday, and if we keep talking, it'll go in one ear and out the other anyway. So if you didn't get on the sign-in sheet, it's up here. Okay. See you Wednesday.